Hi everyone. Today we're going to be completing our notes on 3.4 arithmetic sequences. Now, last we talked about 6.2 and 6.3, and the next section is 6.4, which is geometric sequences. But before we talk about geometric sequences, we do have to talk about arithmetic sequences. This can be found in topic 3, which is earlier on. This was semester 1 for us, but we're going to be revisiting this topic just for this section here, arithmetic sequences. Okay? So I want to start with this warm up. A fashion designer is designing a pattern fabric. In row 1, we have one pattern square. In row 2, we have 3 pattern squares, and then 5 in row 3, and so on for 4 and 5. So we see a pattern in the number of pattern squares in each of the rows. So let's go ahead and fill in the table below. Here we have the row number 1. The number of pattern squares in that row is 1, and then the total number so far is 1 as well. In row 2, we have 3 additional, and so then the total number rises to 4. In row 3, we have 5 squares, and then the total rises to 9. In row 4, we have a total of 7 pattern squares, and then the total rises to 16. And finally, in row 5, we have the total number of squares is 9, or I should say in row 5 is 9, and then the total would be 25. Okay? So what pattern do you see in the rows of the table? Well, I noticed that in the rows are just increasing by 1. That's just indexing the number row. But in the number of pattern squares, we're increasing this by 2 each time. And in the total number, this increases by 3, and then it increases by 5, and then it increases by 7, and then it increases by 9. And so I can see that the number of pattern squares in each row has a constant rate of change. It's adding 2 each time. And then the total number of pattern squares increases by that same number, but plus 2 each time. Okay? So this leads us to what a sequence is. A sequence is simply just an ordered list of numbers that often forms a pattern. Each number is a term of the sequence. One type of sequence is called an arithmetic sequence. The difference between any two consecutive terms of an arithmetic sequence is called the common difference. We can also think of this as like the slope. So when we look at like a linear function that has a slope, a constant rate of change, we see that between any two successive x values, the rate of change, the difference between the y values, is the same for any two subsequent x values. We also use subscript notation when we're talking about sequences. So for example, a sub 3 equals 47 means that the third term in that sequence, a of n, or a sub n, is equal to 47. Okay, so the third term in some sequence an is 47. So go ahead and flip the page. Example 1, let's consider the sequence 26, 39, 52, 65, 78. The first term of this sequence is 26. So using subscript notation, this can be described as a sub 1 is equal to 26. The second term would be 39, which using subscript notation would be a sub 2 equals 39. All right. So we're going to get a lot of practice using this subscript notation, so it's good to be comfortable with this. Now let's talk about recursive formulas. In mathematics, recursive simply means just to repeat a process over and over again, where the output of each step is the next input. So where you would get an output for one step, whatever that output is becomes the input for the next step. A recursive formula relates each term of a sequence to the previous term. Okay, so you have to have the previous term in order to get the next term. You can't just pull some term straight from the middle of the sequence without having the previous term. Okay, so example 2, let's use this picture of this pyramid to answer the questions. So we know that each step is 26 centimeters tall. So if we were trying to get the height of the next step, we would add by 26. So if I know that some step is some height, to get the next step, that height off the ground, is going to be adding 26 because we know that's the height of that step. So therefore, if the 25th step is 650 feet from the ground, how high is the 27th step? Okay, so if we're at the 25th step and it's 650 feet off the ground, and we know that each step is 26 centimeters off the ground, then we know that we can find the next one to be 650. I think this should say centimeters. So go ahead and change that to centimeters. Then 650 plus 26 would give us our 26th step, which is 676 centimeters off the ground. In order to get the 27th step, we have to add another 26 centimeters, and that would be equal to 702 centimeters. Okay. Now let's talk about an explicit formula. It's another way to represent sequences. So an explicit formula expresses the nth term of a sequence, or some number term in the sequence, in terms of n. The explicit formula for an arithmetic sequence is as follows. We have a sub n is equal to a sub 1, or the first term of the sequence, plus the term number n minus 1, that quantity, multiplied by the common difference. So as a reminder, the common difference is that difference between any two subsequent terms in a sequence. All right, so let's go ahead and see how this works. Example 3, the cost of renting a bicycle is given in the table. So if I rent it for 1 day, it costs $26, 2 days, $38, and so on. Let's go ahead and represent this using an explicit formula. So as a reminder, our explicit formula is AN equals A1 plus N minus 1, the quantity, times D, the common difference. Okay, so that tells us that for some number term in the sequence, AN, or some number of days rented, the total cost is equal to our initial amount, the first term, $26, plus the quantity n minus 1 times our common difference. Well, in order to find our common difference, we have to see how each term in the sequence is changing. So I know to get from 26 to 38, we add 12. From 38 to 50, we add 12. And from 50 to 62, we add 12. So that tells me that my common difference is 12. Okay. So if I wanted to find the 10th term in the sequence, or the cost of renting the bicycle for 10 days, we can find a sub 10, which is equal to 26 plus, and we're plugging in 10 for n. So we have 10 minus 1 times 12, and that gives us 26 plus, we have 9 times 12, which is 108, and that's equal to, if we add 26, we get 134. So if we rent this bike for 10 days, it's going to cost us $134. So let's take a look at this here. How is the explicit formula of an arithmetic sequence related to a linear function? A hint, think of how the rental cost would be modeled as a linear function. What's the slope of this function? So if I were looking at this, I know that 1 day costs $26, 2 days cost $38, and so on. These blue points would represent the sequence, whereas the linear function would be this dotted orange line here. If I were to find the linear function that passes through each of these points, it would be modeled as y equals 12x plus 14, which kind of makes sense. Let's see how this relates to our explicit formula up here. Well, I noticed that our common difference is 12. Our 12 here is our slope. So the slope we can think similarly to the common difference. And then that's like the common difference. Okay. Because the minimum number of days that we can rent this bike is 1 day, we can find that initial value, that first term, if we were to plug in 1 into this function. And if we would get 12 times 1 plus 14, which we know is equal to 26. Okay, so that initial value is where x equals 1 in the linear function. So how many days will the bike be rented if the total cost is $170? Well, let's plug it into our linear function, where we have 170 is our y. That's going to be our function output. That is the total cost after x days. So 170 equals 12x plus 14. Solving this, we subtract 14 from both sides, and we get 12x is equal to 156. And then finally, dividing both sides by 12, we get x is equal to 13. So this tells us 13 days would get a cost of $170. Okay, example 4, the first step. Using this image right here, the first step in a set of stairs is 7 inches tall, and then every step after that is 4 additional inches. Write an explicit formula that models the situation. So the first step, this is going to be our A1. Every step after that, this is going to be our common difference, D. So writing an explicit formula, we have AN equals A1, which is 7, plus the quantity n minus 1, times D, which is 4. Okay? All right, so these have been our notes on 3-4 arithmetic sequences. We're going to get a lot of practice on this, so we'll see you tomorrow. Have a great day, everybody. Goodbye.